Now here we're going to explain how to write the expression function for Josephus problem. Josephus problem first gave a brief introduction. First, Josephus is known as a legendary warrior who was surrounded by Roman warriors. During this time, he and his soldiers had to suicide murder in order not to be killed or caught by Roman warriors. So they come up with an idea. Suppose Josephus and his soldiers are totally a number of 10 small group people. So they are. For the rule is start from the first people. The first people first kill the third people, the number 2 people, and then the number 3 kill number 4, and number 5 kill number 6, number 7 kill number 8, number 9 kill number 10, and then what is left is 1, 3, 5, 7, 9, and then start from number 1. Number 1 kill number 3, number 5 kill number 7. So and at this point, number 9 have to kill number 1. So after a recursion, what is left is 1 has gone, 3 has gone, is left is 5 and 9. Because before the recursion, the last one who killed number 1, the last one who killed people was number 9. So number 9 lost the priority. So this time is number 5 kill number 9. So what is left is number 5. Although Josephus is a legendary creature, feature of warrior, but he himself is selfish. He wants to alive. Because when everyone commits suicide, and you see that there's always one people who live in Josephus' problem. So Josephus, a selfish person, wants to be the one who left behind. He wants to survive, so he have to calculate where he could stand in order to be the last survivor. You see, in 10 people, he cannot stand, let's just say, number 4, number 6, or number 7. In these cases, he will die. So only in number 5, he will survive. But how can he manage to calculate such a position in a very short time? So he needs an inspiration. So now today, I stated about Josephus' problem is called a survival problem or place standing problem. So we have to find the correct number that one could survive in the group suicide, let's so-called this one. Now suppose we have n people, and then we let Jn to be a Josephus sequence. And Jn represents the number of all the nth people, and Jn is the place number one can survive. So you see that J10, I will calculate J10 equals to 5. And this is not that complex. I mean, suppose we can generalize the function. Suppose we got n people here, 1, 2, 3, 4, ... and then the final is n. So after committing suicide, you see that after recursion, 2 has gone, right? So we just simply write 1 here because we don't know whether this is odd number or even number. Oh, here, suppose it is odd number. And suppose it is even number. Suppose it is even start from even number. So this is quite obvious that you see when this is even number, 1 can survive, 2 cannot survive. Only odd number will survive. ... And you see, and plus the final person is the smallest odd number, less than n, that is n minus 1. So n minus 1 becomes 1, 3, 5, ... and minus 1. This is when n is even number. After one recursion, this is the people who survive. And you see the odd number, we just forget about, and suppose 1 survives. And you see there's 3 survive, 5 survive, and dot dot dot. And you see, in the following example, we have proved that there's only, after recursion stop here, and that n minus 1 didn't kill anyone, or he didn't killed by anyone. So the final step is this person have to again killed 1. So quite obvious, there's only 3, 5, and n minus 1. Where n minus 1, n is an odd number, n minus 1 is an even number. And here, is even number, n minus 1 is an odd number. So now here we can give an expression for an even number. So if n is even, and after a 1 recursion, we can change these variables. How to change these variables is we use a set of number n, and for n, which is, you can represent that. You see there is n people, n minus n people, right? And so, no, not n minus n people, it is n over 2 people here. Do we have to minus 1? Let's think a second. No, don't have minus 1. And there are n people, there's n over 2 people, so if n is even. So we suppose that the people who kill themselves are 2m, and then forget here we got m. So this is m, we use to represent n. So before they kill themselves, that is j2m equals 2. And because we use we suppose that Jn is the place number 1 can survive. So after 1 recursion, the place number we change our variables. So we represent use like this: 1, 2, 3, 4, dot dot dot. We use 2m here, and here we use 1, 2, 3, dot dot dot, and then m minus 1. We use this. So the question here seems to be quite obvious that j2m equals to jm multiply 2 minus 1. You see here, this position equals to 2m. So 2m minus 2 equals to 2m minus 1. That is quite obvious, because this one was killed, 2m was killed. The one who killed 2m was 2m minus 1. So after 1 recursion for the odd number, j2m equals to 2jm minus 1, and jm is the number of position. That is not the number of people who survive. And following the same rule that for odd number, you see that the one who survived before recursion also express this as 2m minus 1. This is quite obvious, an odd number. So what is left here is the original number of 2m minus 1, but since they are only plus 1, right? There's only 2 squared minus 1 plus 1. No, not they are originally these people, and because this is even number, so this is first multiplied by 1, then subtract by 2. There are still this kind of person, that is m number of people. So we relabel this, it become 1, 2, 3, 4, 5, and dot dot dot. So j2m minus 1 equals to 2jm minus 1 plus 1. Just this is, we just relabel them. This is this is the former step, and this is the step after the recursion. That is, after they kill themselves, the number which the position number where people survive is standing become this one. Just suppose if even number, and suppose if position number 9 survives, and then after recursion, position number 9 becomes position number 5. That is what does it means. So we get these two sets of expression function that for even number, 2m minus 1 equals to 2jm minus 1 plus 1, and j2m equals to 2jm minus 1. Alright, since we get these two expansions, we have to generalize this. So how do we call this? Is that first, you see, if there is only the last person, its label is 1. No matter what number he stand before, and after this recursion, this is final step, he is 1. So J1 equals to 1. So that's the expression for the Josephus problem. You see, get an overview is, suppose you can get from 10 people, and 10 people, this is a special case, you can try to get an experiment on them. Now in 10 people, 10 is an odd number, so after recursion it becomes 5. 10 is an even number, after recursion it becomes 5. And then 5 you see is an odd number, so 5 after recursion it becomes 2 people. So you can get the conclusion that if there is, suppose m is an integer, suppose there is 2m present, and the remainder is m. Suppose m is still an integer, and suppose there are 2m minus 1, that is always an odd number. Though that gives there are only 2m minus 1, and over 2 subtract by 2 number of people. Just if there are 12 people, after recursion 6 left. If there are 11 people, you have to 11 minus 1 subtract by 2, that is 11 minus 1 equals 10, 10 subtract by 2 is 5%. So 11 people after committed suicide only left by 12. So we gave this equation that you see that since we know that it is still here all numbers, suppose, so we first write 1, 2, 3, 4 and to n, and then after that we label from 1, 3, 5. Because 1, 3, 5, that is not what we want, so we relabel them into 1, 2, 3, 4, dot, 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 and over to 2m minus 1 subtract by 2, that is m minus 1. So m minus 1 is relabeled as the new n, and now n equals to m minus 1, that it was relabeled. So you see that the last people who survive here is 2m minus 1. So the 2m minus 1's position was relabeled as m minus 1. So you see the expression gives us here, that is j2m minus 1 equals to 2jm minus 1 plus 1. That is what relabeled from all number. For the even number, we label as this. Here for even number, we give from, suppose we don't know what is what will become, so we just label that there's n people 1, 2, 3, 4, dot, 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 plus n. And so after recursion, they commit suicide. The people survive 1, 3, 5, dot, 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 and to n minus 1 because n is an even number. So what we left here is n over 2 number of people. Just relabel them because 1, 3, 5 is not what we want. Just label 1 into 1, 3 into 2, and 5 into 3. And then we just label, because there are n over 2 people, because so n minus 1 was labeled as new n subtract by 2. So if we remove these two, just relabel them as t. So it's 1, 2, 3, dot, dot, dot to t, and then we can find that t equals to 2n, and you see that n minus 1 was relabeled as t. So you got it here, t equals to 2n. So you got j2m, where this is 2m, obviously an even number, equals to 2jm minus 1. So that's the difference between before recursion, one is odd number or even number. So it gives the expression here as labeled this one. And in the next lecture, we are going to find the most generalized expression for the Josephus problem. Because here you see that there is a difference between odd number and even number, and that should be related to the function we tell that for the repertoire method. So that's all for today's research, and see you next time.